This is Mr. Beck Does Your Homework, homework number 15, question number 15. A child in a sled with a combined mass of 53.9 kilograms, so that's my mass, is 53.9 kilograms, slides down a frictionless hill, good, that is 10.2 meters high, so I've got this hill that's going to be 10.2 meters high. So my height is 10.2 meters. At an angle of 29 degrees from the horizontal, so this is 29 degrees. The acceleration of gravity is 9.81 meters per second squared. If the sled starts from rest, so up here the sled starts from rest, what is its speed at the bottom of the hill? So I'm looking for my speed after it's traveled down here and gotten to the bottom of the hill. Well, up here it's got some energy. Can it fall? Sure, so it's got some potential energy. Is it moving? No, not yet. So my kinetic energy is going to be 0. At the bottom here, I could have some potential energy and some kinetic energy, but it's at the bottom of the hill, so my potential energy gets to be 0 at the bottom. So I know that my potential energy at the top of the hill is going to equal my kinetic energy at the bottom of the hill. What that means is my potential energy is mgh at the top equals my ke at the bottom, 1/2 mv squared. You might notice that mass cancels out. So I'm left with gh equals 1/2 v squared. If I multiply by 2, I get 2gh equals v squared. So I know that my velocity is going to be the square root of 2gh. And that will be a good way to solve this problem. The square root of twice times 9.81 times my height of 10.2 meters. Notice I didn't even need the mass of the kid. I didn't need the angle. I solved this with energy because I know my height here, and that's what mattered, my change in height. So if this hill was steeper or not so steep, it would still give me the same answer regardless of the angle, as long as I start at 10.2 meters high.